Hello everyone. In today's lecture series, we are going to discuss about the decoders. So what is a decoder? It's a combinational circuit that changes the binary information into 2 power n output lines. The binary information is passed in the form of n input lines. The output line is defined by 2 power n bit code for the binary information. This is an application, right? See here in the previous section we have discussed about encoders. So this is how encoding is being done, right? The data are being given and then it is converted into, that is 2 power n is converted to n, and then the transmission will be done. In the receiving end, these packets has to be retrieved back, right, to a human readable form. So we'll be giving it to a decoder. And this is another example, if you see, why decoding is being done. If you see the passwords, when you type the passwords, immediately it changes into a different code which we couldn't read. Have you ever noticed it? This is a decoding, right? Actually, this has been encoding and decoding is very common with cryptography or when it comes to network security. A lot of encoding techniques are being done. So this is another example for decoder. The different many types of decoders are available, and I've given you few important decoders: 2 to 4 decoder, 3 to 8 decoder, 4 to 16 decoder. First, let us discuss about 2 to 4 line decoder. In the 2 to 4 line decoder, there is a total of 3 inputs and 4 outputs. It's again a combinational circuit. This is 2 to 4 line decoder. So here we have two inputs along with an enable, that is very important, and we have 4 different outputs. Until and unless this enable signal is being enabled, so see, initially enable is 0 and the output is also 0. The output is enabled. But when the enable becomes 1, the output is being transmitted. Here you have 1, y0 is 1, y1 is 1, y2 is 1 and y3 is 1. Similarly, we will be having it in a diagonal fashion, both encoder as well as decoder. And from this we will be writing the Boolean expression, right? So when you write it for y0, how will you write it for y0? Here E is 1, so we'll be writing E as such, and then here both A1 and A0 are 0, so A1 dash, A0 dash. So similarly for all the 4 sets, we'll be writing the Boolean expression. Once after writing the Boolean expression, we'll be drawing the circuit. Next, 3 is to 8 line decoder. The 3 to 8 line decoder is also known as binary to octal decoder. In a 3 to 8 line decoder, there is a total of 8 outputs. And the circuit has an enable pin. Just like 2 to 4 decoder, when enable E is set to 1, one of these 4 outputs will be 1. Here if you see, the output is 8 to power n, and here the input is n, and one more enable line also should be here. And this is a truth table corresponding to 2 is to 8 line decoder, right? Sorry, 3 is to 8 line decoder. And these are the 3 inputs, and this is the enable. When the enable is 0, no output has been passed. When an enable is 1, right, the outputs are being passed. And once after framing the circuit, once after framing the Boolean expression, we can draw the circuit. All these minterms are having AND gates. So AND gates and NOT gates for the 3 different terms. And this is your assessment part. So write any 2 applications of decoder. I have mentioned many applications of decoder.
So I hope you all have understood what is meant by a decoder, why a decoder has been used, and how to design it. Thank you.